Hi folks, Dr. P here. This is question number 26 from the rational equations and expressions unit. So in this case here we have two rational expressions. They're asking us to state the non-permissible values, to solve them algebraically, to verify the solution, as well as verifying it by graphing it on our calculator. Okay, so what we're going to start with is we're going to state the non-permissible values here. So we pull out the denominators, 2x minus 8, and we equal them to 0 for both of them. And then we solve it for x. So here we're going to get plus, we add 8 to both sides, divide by 2, so it's going to be 4. Over here, we add 12 to both sides, divide by 4, and we're going to get 3. So the non-permissible values are 4 and 3. Now we're going to solve this one. So I'm going to start by moving the right-hand side expression over to the left-hand side by subtracting it from both sides. So I'm going to be left with, on the left-hand side, we're going to have 1 over 2x minus 8. Minus 1 over 4x minus 12 equals to 0. Then we're going to find the lowest common denominator. Actually, before we do that, if we take a look at the denominators, we can see we can factor them. So let's start by doing that. We can factor the denominators. So here, if we take this one, we can factor out a 2, and we're left with x minus 4. Over here, we can factor out a 4, and we're left with x minus 3. So now we have a lowest common denominator. So 2 and 4 is going to be 4, and then we have x minus 4 times x minus 3. That's our lowest common denominator. Now, our goal here, in order to solve this expression, is to get rid of the variable in the denominator. And the trick we're going to use here is that we're going to multiply each one of the terms. So this term, as well as the term on the right-hand side, by the lowest common denominator. So we're going to write it out here, which is going to be 4 times x minus 4 times x minus 3. So that's our lowest common denominator. We're going to multiply by the first term. In the denominator here, I'm not going to write the expanded form. I'm going to use the factored form. So this is going to be 2 times x minus 4 minus, and then we're going to multiply the second term by the lowest common denominator as well. So it's going to be 4 times x minus 4 times x minus 3 times that second term. And then on the right-hand side, we're going to multiply the 0 by that lowest common denominator as well. Now, we don't have to write this out because 0 times anything is 0. So it's just going to be 0. Now, if we take a look at the terms that we have here, we have this term over here. What we're able to do is we can cancel this x minus 4 against this x minus 4. And it's 2 against this 4. We're just left with a 2 here. 4 divided by 2 is 2. So we essentially got rid of the denominator. For the second term, I wrote down the wrong form here. So here it says 4x minus 4. That's the original expression right there. What we want to use is the factored form. So I'm going to change that. Let's see if I can. I want to use the factored form here. The factored form is 4 factored form is 4. Hold on. All right. 4 times x minus 3. And again, we can cancel the x minus 3 against the x minus 3, the 4 against the 4, and we got rid of that denominator. So let's write out what we're left with. We're left with, here we have 2 times 1, which is just 2. And then we're left with this x minus 3 minus, and here we're just left with x minus 4 equals to 0. So we now have eliminated the denominator, the variable in the denominator specifically, which will allow us to proceed here and just simply solve this for x. So I'm going to start by expanding this. So 2 times x is 2x. 2 times negative 3 is negative 6. I'm going to drop the brackets, but because we have a minus sign here, all the signs in the bracket will change. So it's going to be negative x plus 4 equals to 0. Combine like terms, 2x minus x is just x. Negative 6 plus 4 is negative 2. Add 2 to both sides, and there's our root. X equals 2. So we solved the equation algebraically, and now they want us to verify by replacing the answer in the original equation. So what we're going to do, we're going to verify algebraically. So we're going to replace the x in the original expression with 2. So we're going to get 1 over 2 times 2 minus 8 equals to 1 over 4 times 2 minus 12. So this is going to be 1 over 2 times 2 is 4, minus 8 is negative 4. So negative quarter. 4 times 2 is 8, minus 12 is going to be also negative quarter. So we have shown that the left-hand side equals to the right-hand side, which is what we want to see. Right? So it means that our root is valid and we're good. And then finally, they also want us to verify by using the intersection feature of a graphing calculator. So we're going to move over to the graphing calculator right there, and we're going to be graphing that original expression right there. So we're going to put those, the left and the right hand side, in a separate expression. So y1 is going to be the left hand side, y2 is going to be the right hand side. So 1 divided by. Now you have to keep in mind here that if we look at the denominator here, when you enter this in the graphing calculator, you have to put brackets around the denominator or you're going to get the wrong function. So I'm going to have an opening bracket, 2 times x minus 8, closing bracket. So there's my left hand side. Same thing with the right hand side. Again, brackets around the denominator, 4x minus 12, closing bracket. And then we graph. There's the first one, and there's the second one. So it's a little bit hard to see, so what we are going to do here is we want to zoom in. What we're looking for is the x-coordinate where these two graphs cross each other. Okay? Now we can see that nothing is really happening on the left-hand side, so in quadrant 2 and 3. So we're going to eliminate those, and we're going to zoom in around this point. We're going to do that by changing the window settings. So x min can be 0. We're not interested in negative x values. X max, we can probably go from 10 and lower it to 5. Y min, negative 5. Hope that was supposed to be 5. And then y max, positive 5. So let's graph it now. Here's the first curve. There's the second one. Okay, so this graph looks a little bit confusing. All right, so I remember how I said that we're looking for the x-coordinate where these graphs are crossing each other. Well, you might think, well, they're crossing each other right there. Looks like they're crossing each other right there as well. No, they're not. It's just sort of a limitation of these calculators. These lines here are actually not present, which, yes, I know it makes perhaps not much sense, but I'll show you in a different view in a bit here why that is. We know that the root is 2. We did it, where is it here? We know that they should be crossing at x equals 2. Well, x equals 2 is right there, and it's really hard to see what's going on there. So what we're going to do, we're going to zoom in right around x equals 2. So we're going to go into window settings, And our x-min, let's zoom in quite a bit. Let's set our x-min to 1.5, our x-max to 2.5, so that's sort of on each side of the point of intersection. And then our y-min, we can set that, we can try negative, I don't know, -1 and +1. And then we try and graph it again. There's curve number 1, the left-hand side. And there is your right-hand side. So I think we need to zoom in even a bit more. So my y-min, I'm going to set that to -0.5. My y-max to just 0.5. There's your left-hand side. There's your right-hand side. And you can now sort of start to see that the right-hand side, the second curve that's being drawn, starts above the right-hand side. And then it crosses it right here. This is x equals 2. Okay? We can zoom in even more. We can actually set our y-max to 0 because it's below the curve, below the x-axis. There is left-hand side. There's right-hand side. Right there. That's our x-intercept. Not x-intercept, our x-coordinate of the point of intersection. Okay, so this question is asking us to use the intersection feature of a graphing calculator to find the x-coordinate right there. So once we can see that point of intersection, we can now see it quite clearly. We're going to go to second, trace. We're going to use the intersect feature, so that's step number or option number 5. And then it's just saying first curve, which it is the lower one on the left-hand side. I'm just going to move the cursor to the left. You can clearly see it's blinking on the first curve. Now it's blinking on the second curve, so that's all good. Enter, enter. And there is our x-intercept. So this just verifies that the root really is 2. It's right there. Okay. Now, what I'd like to quickly just do, let's see if I can pull this off here. I'm going to need, okay, so that should work. I'm going to very quickly just graph them in a different way, just to show you that those vertical lines are not actually there. If this works. Maybe it's not working. So this is an online graphing calculator, and it's not really cooperating. All right, so I don't think I can show you this then. Let's see if we can. Let's try this. Yeah, so I don't know what's going on. This is not supposed to. It's not supposed to look like that. Yeah, so it's not cooperating at all. So I'm not going to be able to show you at this point, I believe. Not sure why it's not Desmos. Maybe. Oh, there we go. Okay, awesome. So now what I'm going to do is, this is just another tool you can use that's online. I'm going to graph the left-hand side, which is 2x minus 8. The right-hand side was 1 divided by 4x minus 12. So here you can now see clearer what's going on, right? So let's look at the left-hand side first. So it comes up here from negative infinity along the x-axis, and then it takes off and goes towards negative infinity along the y-axis. And then it comes back here. As soon as you've crossed x equals 4, it comes back from positive infinity, down, and then it's approaching the x-axis. There isn't actually a line connecting this point down here and this point up here. Okay, so this is just a limitation of the graphing calculator that we're using. It's putting a line there. It wants to connect those points, but there isn't actually a connection there. And same thing with the right-hand side. It looks very similar. If we display both of them and then we zoom in around x equals 2, we can clearly see that, yes, they are indeed crossing each other right there. Okay, so I hope that helps. Now, let's go back to this question here, and we do have... There's a B question as well, right there. So let's do the same thing with the B question. We are first, we want to state the non-permissible values. If we look at the denominator, we can see that it's going to be plus, positive, or negative 1. Those are our restrictions. Now we want to solve this. So again, I'm going to move everything over to the left-hand side. So we have 3 over x plus 1 minus 2x minus 3 over x minus 1 equals to 0. Okay. Now our lowest common denominator here is going to be x plus 1 times x minus 1. So we're going to do the same thing we did in question A, where we're going to be multiplying each term by the lowest common denominator. So x plus 1 times x minus 1 times the first term, so it's going to be 3 over x plus 1 minus, and again, the lowest common denominator, times the second term, which is 2x minus 3 over x minus 1 equals to 0. And now we can see that we can cancel the denominators. This x plus 1 cancels this x plus 1. This x minus 1 cancels this x minus 1. So let's write out what we have left now. The first term we just left with 3 times x minus 1. And for the second term, we're left with x plus 1 times 2x minus 3. Now we're going to expand this expression, so it's going to be 3x minus 3. Now because there's a minus sign here, I'm going to put this expansion of these two binomials in brackets to start with. So we're just using FOIL here. X times 2x is 2x squared. X times negative 3 is negative 3x. 1 times 2x is 2x. 1 times negative 3 is negative 3. Equals to 0. Now I can drop these brackets, but because there's a minus sign in front of the first bracket here, opening bracket, all the signs inside of the bracket will be reversed. So we're going to get negative 2x squared plus 3x minus 2x plus 3 equals to 0. And now we can combine like terms. So let's start with the highest order term. We have the negative 2x squared. There's no other x squared terms. It's just going to be negative 2x squared. I like to cross out the terms I've combined so I don't forget or double count something. We have 3x plus 3x, that's 6x, minus 2x, that is 4x. And then we have negative 3 plus 3, that just cancels, and we're left with this. Okay. Now we want to solve this. We want to find what x is. So at this point, what we can do is we can factor this expression. We can factor out a negative 2x, greatest common factor, which means we're left with x and negative 2. And now we can see that using the zero product law, we can see that x equals to either 0 or x equals to positive 2. So those are our two roots. We want to verify algebraically first. And so before we actually proceed, we want to make sure that these two roots are not non-permissible values. So if we go back up here, we can see that our non-permissible values are positive and negative 1, so that's good. So these are valid roots. Now we're going to verify. And for the verification here, you have to do it twice because there are two roots, right? So we just plug in those roots into that original expression. It's going to be 2 times 0 minus 3 over 0 minus 1. Okay. So on the left-hand side, we're left with 3 over 1, which is just 3, right? On the right-hand side, we're going to be left with negative 3 over negative 1. And this is the same thing as this 3 over 1 is just 3. Negative 3 over negative 1 is also just positive 3. So the left-hand side equals the right-hand side. Then we have to do the same thing with the second root, right? We have x equals 2. So we're going to do the same thing. So it's going to be 3 over 2 plus 1. That's your left-hand side. Right-hand side is going to be 2 times 2 minus 3 over 2 minus 1. So over here we're going to get 3 over 3 on the left-hand side. 2 times 2 is 4, minus 1 is 1. 2 minus 1 is 1. Now 3 over 3 is just 1. 1 over 1 is also just 1. So again, left-hand side equals the right-hand side. So we're good. And then finally we're going to do this on our calculator as well. So we're going to go in here, going to remove the previous four functions, and now we're going to plug in left-hand side first. So 3 over x plus 1. X plus 1. That's your y1. y2 is going to be, we're going to put the whole numerator in a bracket. So 2x minus 3, closing bracket, and then we divide x minus 1. I said should be minus. Like that. Then we graph it. And now, of course, we're having the old Windows settings, which probably are not going to work. We changed them, I remember. So we're going to go back into Windows settings, and we're going to set them to the default values. So from negative 10 to positive 10 along the x-axis. From negative 10 up to positive 10 along the y-axis. Graph it. So there it is. Now we know, so yeah, it looks complicated again, and again, those perfectly vertical lines are not actually there. It's the same sort of problem as in the previous, in A here. So it's sort of an artifact of how these calculators work. If we look at our solutions, the functions are supposed to be crossing each other at x equals 0 and x equals 2. So what we want to do is, let's sort of zoom in around x equals 0 and x equals 2. And we can sort of make out that, yeah, this is probably x equals 2. But it's hard to tell, so we need to zoom in. So x min, so we don't have to go so we want to see x equals 0, so maybe we can go down to x equals negative 1. And x max would be 3 maybe. And then for y min, let's just double check again the graph. Yeah, there's 1. Yeah, so nothing happens below the x-axis. That means that for the y min, we can set that safely to 0. There's left-hand side, there's right-hand side, there's one intersection point, and there's a second. Okay, so there are 2 points where they're crossing each other, and we need to find both separately. So I'm going to go second, trace, intersect, and there's the cursor blinking on the first curve. Now, because there are 2 points of intersection, the calculator isn't smart enough to find both of them at the same time, or it's not able to figure out which one you actually want. So let's start by looking for the left-hand point, this one here. So what we want to make sure, when it says first curve and you see that cursor, you want to move that cursor closer to that point of intersection, closer to that one than to the other one. That way the calculator gets the hint that this is the one we're looking for. All right, so we got a very odd number here. So this is supposed to be x equals to 0. Okay, but what does it actually say? It says, it's really tiny, but it says 3.6 e to the power of 14, I think. E to the, okay, I'm going to have to write this down. So what it says there, and this will likely happen occasionally. So what it says, let me just move this over here, over here. And again, this is sort of an artifact of these calculators, the way they work. Oh, I can show both, I guess. So it says x equals to 3.68. X equals to 3.68. And then it says e negative 14. Is that what it says? Yeah. What this means, the e means exponent. And this is scientific notation in these calculators. This is the same thing as 3.68 times 10 to the power of negative 14. This is how we know traditionally how scientific notation looks. This is a very, very small number. It means that we have 14 zeros in front of this 3. So it actually says 0 point, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 3, 6, 8. This is what this means, okay? This is a very, very small number, and essentially what it is, it's a round-off error in these calculators. This is, for all practical purposes, in this example here, this is equal to 0. And, you know, you'll find that when you use these calculators for these sort of things, sometimes you get these really, really tiny numbers that really, like in this case, really mean 0. Sometimes you would get exactly 0. If I do this again, I might get 0. It's just the nature of these beasts, and you just need to recognize that this is a very tiny number, and you should be rounding it off to 0. Okay? Let's find that right intersection point as well. So second trace, again, intersect. Now we want to move that cursor closer to that right-hand intersection point, somewhere over there. Enter, enter, enter. And this is supposed to be 2, and this, 2, and we got exactly 2. But you could have also got 1.99999, and the implication being that you need to round that to 2. Okay? All right, I think that's everything. This is a large question. I think we've covered everything here. I hope that helps. And until next time, see ya.